Hi, folks. Welcome to our inaugural Cloud Basics class, or really Meetup. We wanted to cover some of the basics of cloud technology and hopefully get folks to maybe get a better understanding of how cloud works, why cloud works, things of that nature. We had a bit of a technical snafu this afternoon, and hopefully the video will come through and the audio will come through, and we'll be able to get some good knowledge transfer. Everybody should be muted initially. That's so that hopefully we can keep the background noise down to a minimum. Um, Certainly, if you have a question, feel free to unmute yourself and ask the question, and uh, that way I think everybody will get a chance to learn. Um, and at the end of the session, the little presentation that we have pulled together for you guys, we'll have a Q&A session where I think we can all join in and answer questions as they come up. Looking forward to this, and hopefully this proves useful to everybody. We'll see. I'm going to try to launch the video, and we'll see how, or not the video, rather the presentation that I have, and we'll see how well that works. All right, so I'm going to switch over to hopefully a PowerPoint, and we'll share this and sort of get started. Great. So the goal for this initial little session was to do an introduction to cloud computing. Really sort of cover the basics of cloud, what it is, what it means, and specifically, I really wanted to go through the National Institutes of Standard and Technology cloud model because I think that really gives everybody a good solid basis for understanding cloud. So the first thing is we want to define clouds. And we can say, well, we know what clouds are. Here are a set of different clouds. And this is a taxonomy that meteorologists use to describe clouds. Well, of course, we're not talking about this class of cloud. We're talking about a different technology for cloud. But in much the same way, I think it's good for us to have a taxonomy, a way of describing what clouds are, how they look, and how they sort of fit together to make this a meaningful discussion. So I usually like to ask, what does cloud mean to you? How would you go about describing cloud? Because that's one of the tools that we use to figure out what a cloud is. And here, of course, we're talking about a data center cloud or an IT-derived cloud, cloud in the computing sense. But still, the cloud definition is how you end up defining it. Well, like I said, the real thing that I wanted to talk about and that I thought would be useful to everybody was to talk about cloud from the National Institutes of Standard and Technology model. So NIST, for those of you that aren't in the U.S., is the U.S. National Institutes of Standard and Technology. They're basically a government body that's intention and their reason for being is to define things. So along the way, as this concept of cloud became important, the community reached out, the government community reached out and said, hey, look, we need a decent model for this, a way to describe this so that we're all talking about the same thing. Much like meteorologists have ways of talking about cumulonimbus and stratus and cirrostratus clouds, we wanted the same sort of thing for our data center cloud technologies. And they came up with this model that said, well, there are really sort of three main domains that we can talk about. And with those domains, we can break it down into a couple of key characteristics. So we start out with the essential characteristics: measured service, elasticity, on-demand, broad network access, and resource pooling. Those characteristics can be used to define a cloud. And once we have those characteristics, we can start talking about service models, another way of describing clouds. Are we talking about software services? Are we talking about platform tools? Or are we talking about infrastructure? And then lastly, there are the deployment models, or effectively, the way I like to think about it, the how do you consume these resources? Is there a question? All right. So with that, if we sort of dive a little deeper, let's talk about these essential characteristics, because this is, I think, really what defines cloud in these models. Firstly, we have things like measured service. If we have a cloud, if we have a set of resources, we need to be able to measure them. And the measurement is sort of a basis for describing how much of something has been used. it turns out that measuring service is one of the things that we need to do in order to provide an on-demand service. How much do we have? How much have we consumed? How much is still available for use? Is a very important characteristic of defining something as a cloud. Otherwise, it's just a set of static resources that we don't necessarily get the flexibility, the on-demand aspect of. In fact, I think actually I should probably start with on-demand self-service as really sort of the initial essential characteristic. I consider this actually the base characteristic because much like I can say I can measure something, but just measuring it doesn't mean that it becomes cloud. What really defines cloud to me is this concept of on-demand and self-service. We've had IT for a long time. We've had automated IT even for a long time. We've even had automated IT against virtual environments, for all that matters, for a very long time. But the concept of an on-demand service, something that I can just request and immediately get that service, is the real big shift. This is the crux of cloud today, at least IT-driven cloud. And so for me to do this, I need to be able to measure it. I also need elasticity. If it's going to be on demand, I have to be able to request it and get it. That's one aspect of elastic, right? But if we think about a rubber band or an elastic band, if I stretch it and I let it go, it returns to its original shape. And this is the other half of elasticity. I think this is actually for some people, especially for people that think of IT as a service that gets consumed and not released. This is probably the biggest negative in terms of defining cloud and cloud service. Elasticity goes both ways. We want to be able to expand our resource, but we also want to return it back to a pool. And a pool is then the thing that we're expanding and contracting from. If we have a pool of resources, a pool of computers, a pool of disks to consume storage from, a pool of network bits, basically, how much bandwidth do we have available? Can we share that resource? This resource pooling is a very important aspect to cloud and cloud definitions. Right? But all of these things, being able to elastically create and release resources, being able to get a pool of resources that we can now share much more efficiently because we can release and return those resources, all of this is useless if we don't have access to it. And from an IT perspective, that means broad network access. Now, the NIST model doesn't specifically call out network access as something that provides internet access, global internet access to everybody. What they describe is broad network access for the resource group. So when we talk about public and private, we can talk about broad network access within a private domain. So within in an enterprise, or from the government perspective, even within a security context, they actually talk a lot about secret and top secret being separate security entities that could have different network access requirements, but still I can get access to these resources from where I am located, basically enabling this on-demand and self-service aspect rather than where somebody else is located. So we take all these essential characteristics together. I can measure the service so I know how much I've consumed. The other key thing about measuring the service, especially from the perspective of the cloud, is once I can measure it, I can also potentially bill for it, or at least show back the information of how much has been consumed and potentially how much has been released. From the perspective of cloud, I think the only reason cloud works the way it does, for example, an Amazon-based cloud is an example of this, is because you can charge for it. Because it's been shown over and over and over again, and in my many years of running IT systems, I have seen it over and over and over again. If I don't have a way of charging you for it, showing you that the use of a resource actually has a cost to the organization or to the company or even individually, there's a very low likelihood that I will ever return that resource back to the pool. I'll start consuming it, and I'll just continue to consume it until I'm basically out of resource. And only then do we get the request for, hey, can we clean up these resources? Is there anything you can release back? If I don't have a way of measuring that service, I really don't have a cloud. I really don't have a way of forcing a user operation that says, yes, I will release resources because I see that there's a cost to the community for me to use these. So these are the characteristics. This is how you define what is or isn't cloud. Right? And I find that in many cases it's very easy to use these characteristics to define something as a cloud. A classic example, I've talked to so many companies that have deployed things like VMware tools. And I have no issue with VMware tools, by the way, but in general, when VMware tools are deployed, they're deployed to provide virtualization, which is, from an IT perspective, a way of creating a resource pool. hey, this is one of my essential characteristics. Probably I even have a way of measuring that service. As an IT vendor, IT user, I have a way of measuring how much of my virtualization has been consumed. And as an IT resource, I can provide elasticity. I can add more or remove from the consumed resources in my virtual domain. And I even have broad network access. So from this perspective, 4 of my characteristics are met by virtualization, just as a general component of my environment. But what we found is that most people that deploy virtual machine environments using the VMware model, unless they own that entire VMware system for themselves, and effectively have created an ultra-private environment, they often don't have on-demand self-service access to those resources. Often they have to make a request to an IT department, sometimes even through something as old school as a faxed document that says, I need more capacity. And that breaks the self-service aspect. So while you certainly can build a cloud with VMware tools, and I'm not trying to say you can't, I've seen so many environments where people say, yes, yes, I have a cloud, I have virtualization. Virtualization does not make a cloud. On-demand self-service with a virtualized backend can make a cloud as long as our essential characteristics are met. So essential characteristics really are a way of describing what is a cloud, what isn't a cloud. And it's, again, it's part of this taxonomy. Can I describe this in a way that around the world we can have a consistent definition of a cloud and cloud technology? So I think incredibly powerful when we look at it from that perspective. Another model is the service model. Service models, things like SaaS and PaaS and infrastructure as a service, are ways of describing how I'm bundling these resources together. In a sense, what resources am I pooling? What resources am I providing elastically? Are folks still able to see the presentation? Sorry, I just got a note that says that the presentation is over. I'll take that as that things are okay. So with our service models, we look at software as a service, we look at platform as a service, we look at infrastructure as a service. Again, these are models of how am I consuming or managing this pool of resources? What is the resource that I am pooling to build my cloud? I think that the easiest one for most of us to understand, at least from a data center services perspective, to understand is this concept of infrastructure as a service. Infrastructure as a service is what it tries to describe. I'm going to take the data center infrastructure, so my compute systems, my x86 servers is the most common sort of model for this, my storage systems, so my shared network attached disk subsystems, and my network environments and my network components potentially even, and use these components as infrastructure. And I'm going to provide that as a cloud service, which means that I'm going to provide a pool of compute, network, and storage. I'm going to provide a pool of these resources in a elastic fashion, so I can add them and remove them at will. And I'm going to provide access to this via a broad network service. I also am going to enable some form of measurements that I know how much has been consumed. And again, in its best iteration, I will measure that service and provide some form of a bill or model that shows the consumption of the resource relative to potentially one's peers, or actually charge you for that resource so that you have the impetus to release resource when it's not being used. That way we all get to share in that resource domain. So from the infrastructure perspective, it's often straightforward. I count the number of computers I've used. I count the amount of network bandwidth I'm consuming on a consistent basis, or the number of network services like load balancer resources that I'm consuming on a consistent basis. How much storage have I locked up and consumed in my cloud environment? That's infrastructure as a service. So again, from my perspective, the simplest of these to understand. The other one that I think is fairly straightforward to understand is software as a service. In this case, a software package or a software system, classic would be something like a mail application, email application. I think the most widely known worldwide probably at this point is Google Mail or Hotmail, or even Yahoo's mail service. These services are cloud services. I can ask for a resource. I would like a mail account. That's the software resource that I'm consuming, and I can ask for it to scale up and down. I can make some changes to it, and I can also return it back to the pool. I can say, I no longer need this email account. Go ahead and delete it entirely. Most people don't do that to their email accounts, but this is the concept, right? I have the ability to increase or decrease the capacity or capability of my resource and release it entirely. So that's software as a service. Now, more commonly, people are talking about things like enterprise resource management or resource planning, ERP type systems as software services. Another common one would be something like the Salesforce tool sets to provide both customer relationship management or enterprise resource planning capabilities in that software service. There's the entire Google suite of online tools or Zoho tools. There's a whole bunch of these sorts of software as a service capabilities that describe the capabilities of cloud and cloud services. But we're really talking about software. And again, the same things apply. Am I able to measure it? Is it rapidly elastic? In other words, can I ask for it and get it effectively immediately? That's what we think of today in terms of what do we expect from our cloud. Immediate might be a couple of minutes, or maybe worst case even an hour, but it can't be days or weeks or years. That's just against the concept of what I think most people expect from their cloud today. Broad network access, I should be able to get at it from anywhere within a security domain, within a resource management domain, so within my enterprise, for example, or within a security zone within my enterprise. Um, and it's a pooled resource, so if I need more, I should be able to get at it. There are, of course, always going to be some limits to that, but from a software perspective, those limits are often very large and very hard to hit. So software makes sense, infrastructure makes sense, but then there's this one in the middle, and this is, I think, to me, it's the catch-all bucket, platform as a service. Platform is interesting because I've seen it described so many different ways. With the platform as a service option, we talk about platform as a service as something that is a set of components from which you might build a software service. At least that's the way that I've seen it best described. So a classic platform as a service cloud service would be database as a service. So I can build a database on top of an infrastructure as a service play. I can use a database in a software as a service cloud play. But a database as a service is often not useful in and of itself, except for as a piece of a larger platform, something else that you would consume. Now, database as a service turns out to be a very powerful and very, very meaningful platform component, but often I would tie that together with a web scale service, so potentially a web service or a web server front end with an embedded application. And I might actually deploy that web server and its embedded application on an infrastructure as a service play, but I don't have to manage the entire database other than through the platform capabilities, things like automated backups and maybe automated recovery of my database that the platform enables. So there's a lot of power there. Platform as a service is also the environment where most people now map the container as a service systems model. Now, people talk about containers as a service as effectively an alternative or yet another extension to the infrastructure as a service model as well, but I really see it as a platform environment because a container as a service offering often includes embedded other resources. So it manages network service, it manages load balancing service, it manages scale up, scale down monitoring for your services as a part of the container services deployment systems model. And that's a powerful platform component. Often that's not the end result or the end component of what you would build. You're going to build something on top of it, much like you would build something on top of infrastructure as a service. In the end, we're looking to provide application environments. But these are the service models. So these are the ways that we can think of services that would be applied on top of a cloud. Now, people talk about X as a service, XaaS. And I think that the service models are sort of expanding, but I think you can still always lump them back into one of these three domains. Is it a software service altogether, an entire packaged component that provides a software function that you use repeatably? Is it a platform component, something that you would build on top of, but it's still software? So you could call it software as a service, but maybe it's not as complete a service as something that you would actually then be able to provide an end user as an end component. And lastly, of course, infrastructure as a service. Again, I think this is the one that's most straightforward because we're really talking about those base pieces of resource. And you'll notice that across this entire set of service models and even the essential characteristics, nowhere in here have I actually mentioned virtual. Now, I might have said virtual when I'm talking about these components, because it certainly is easier to provide a pool of compute resources by making them virtual. But there's nothing to say that I don't have 100 physical computers, for example, and those are my compute resources, or 100 physical attached disks that I can map into my compute resources. Those could be the resources that I'm pooling. There's actually a benefit to that, and we're seeing more and more cloud deployments that include physical resources as part of the pooled resource environment. Um, so while we don't call out virtual specifically, and actually the NIST model doesn't call out virtual specifically, virtual is actually a service component that is very powerful for building clouds because it allows for more resource, more pooled capabilities, and more shared elasticity. Also, it turns out that often virtual resources are faster to deploy. To deploy a physical server often takes minutes, many minutes to even hours to actually get the entire system deployed and up into a running state. For the most part, I've seen, especially with x86 compute environments, I've seen that the deployment time usually is something on the order of 10 minutes. When I virtualize that and create a virtual compute resource, often my resource deployment time is on the order of a minute or so, if not even less. And with the container model that is becoming prevalent today, we're seeing resource deployment times in the form of seconds, if not even less than a second in certain instances. So we're seeing some very powerful components. The same is true for software platform services. Often these services, especially if they're leveraging either a container model or a running, especially in the software space, a running system that is effectively just creating a new database entity, often the provisioning aspect of that is practically instantaneous. The thing that takes time would be things like billing integration and validation, or potentially if a backend physical resource has to be provisioned, that physical resource provisioning time is something that takes time. An example there as a service deployments take plenty of time, potentially on the order of hours if you have a very large database that you're deploying that actually has to have some base resource written into the database environment or the database structure. That aspect of the system, the time it takes to write a bit to disk, for example, doesn't change just because we're doing this a different way, building it in a cloud sense. It still is a very consistent function. So we've talked about essential characteristics. We've talked about service models. The last aspect of this is the concept of a deployment model. So in the deployment model, really what we're talking about is how is this cloud accessed? Now, we talk about public and private most commonly, where we say, hey, I might have a public cloud, which would be something like an Amazon or a Rackspace or an IBM SoftLayer or one of many others, and I'm not trying to exclude anybody from this list, but just as a set of examples, these are cloud environments. Often they're focused on infrastructure services, at least in the model that I tend to think about, so the ones that I just named tend to focus on the infrastructure service offerings. But they're starting to encroach from the infrastructure perspective, they're starting to move up the services model stack, providing platform services. And then there's the inverse. There are folks like Salesforce.com, which is a very common CRM or ERP set of tools that also provides the ability to basically use their environment as a platform. In fact, at one point they acquired a company called Database.com that was providing database as a service, so a platform service, at least in the way I've been describing platform, and providing that in a public sense. So a public platform as a service that provides software as a service functions in an ERP or CRM class service environment, or platform services. They don't necessarily provide infrastructure as a service, although I believe they also acquired the Heroku tool, which to me still fits into the platform space. We'll talk about that more if we have time a little bit later. So there's the public model. Effectively, anybody can get access to it. Again, that measuring of service becomes very important because often in the public model, there is absolutely a billing component. You're going to pay for this resource if you're going to use it. And that alone is a very important aspect to making this cloud environment functional. In fact, again, I can pay for it. I can tell you you're going to have to pay for it. And if you can't pay for it, I'm going to take the resource back. I mean, that's the extreme version of this. Within enterprises, it's usually, let me show you what you've consumed. Do you really need that much? Because this is consuming something against the entire enterprise, and we should try to share to make sure that the enterprise stays successful. Am I not sharing any slides? That would be very sad. But if that's the case, then I need to figure out how to do that. Well, let me carry on. Hopefully, I am actually sharing some slides, and uh, because I think this is much easier to understand if you're not just looking at me chatting, looking into the distance. Um, so the other principal model that people talk about is the private cloud model. Private clouds are kind of interesting, and the private cloud is really something that provides a this exact same elasticity, resource pooling, measured service, on-demand service, all these essential characteristics, but in a private sense. And private, at least in the NIST model, is specifically described as having limited access to the ability to make the requests, basically the ability to make these on-demand systems requests. Well, that private model is really important, right? Because the private model is one that people keep talking about. Hey, in my enterprise, I can actually leverage the kinds of services I would get from a public cloud, something like an Amazon or a SoftLayer or a Salesforce, etc. But I can actually do that in my own environment for my own enterprise use. And we're seeing that that becomes a very powerful tool, especially when mapped to some of the other technologies that we'll talk about over the coming weeks and months of this meetup. When we can talk about things like the DevOps environment, or what I like to think of as Ops Dev, so the operational development environment or the development environment that leverages operations. Being able to use these tools, being able to automatically request additional resource in order to run another test and then release that resource back, these are the sorts of things that make cloud meaningful and certainly have made it a very popular solution in the public sense. I use a number of different public clouds myself just for the different day-to-day tasks that I have for the businesses that I run. But when I actually have a big enough company to justify buying hardware because I'm using it consistently, then having a private cloud gives me those same sets of capabilities, the elasticity, the functionality, the flexibility of a cloud, but in a private sense, something that is only available to me, so I'm not suddenly trying to share resources with the world. Very powerful kind of capability. There's also a concept of a community cloud, and this is kind of an interesting one. Again, I think this is maybe a little bit more government focused than otherwise. There certainly are large system level community clouds out there. An example is a national stock exchange in the U.S., the New York Stock Exchange, actually has a cloud that is shared amongst all of its stock exchange members. So these are different business entities that actually get to share a resource, but you or I, the general public, can't actually get access to this resource. So this is a community that has gotten together and said, we're going to provide this elastic resource to all of our members. Yes, there's a cost associated with that. There's a benefit to that because you live within a better network access, for example, to the resources that you would want to communicate with. But it's available only to a very specific community of resources. Another way of describing that community, again, from the government perspective, is the different levels of security. You might have a top secret cloud, but has a number of different entities. So you might have, for example, the different military branches or the internal security branches that all talk to that same cloud at a specific security level. So they are different entities from that perspective, but they're sharing a community that is only available because of a specific thing that holds that community together. So this was a description, again, I think this was one that was driven more by the government aspect of the NIST model. And so to me, it's a little bit less useful in most discussions, but still something that we can continue to discuss. For some reason, apparently, I'm not actually sharing the slides, and so I'm a little confused about that. I don't know if maybe I'm sharing them now, so I'm just going to leave it on this page and see if this is enough for us to actually talk about it. So if you've been able to follow along without slides for the last about 20 some minutes, good for you. Hopefully this particular slide helps describe this a little bit more efficiently, and maybe we'll do a recording of this after the session to post so that you actually get a view of this. But anyway, so when we were talking about cloud, again, I'm talking about the deployment models: public, hybrid, community, and private. So the last one of this bunch is really the hybrid model. The interesting thing about the hybrid model is that this is one that I think the name has been taken and spread across so many different possible meanings and uses. The NIST model for hybrid cloud specifically means, how do I gain access to this environment? What does this look like? And when I talk about accessing the environment, I'm really talking, apparently still no slides. This is so odd. Anyway, so again, sorry about that pause. So hybrid cloud is an interesting one because in the hybrid cloud model, really what we're talking about is cloud that has multiple different deployment models associated with it. So a public plus private cloud could be considered a hybrid cloud. And often people do talk about it in that sense. But also people talk about hybrid clouds as being a different service model mashed together. So a software as a service and platform as a service. So you could say that the Salesforce.com service cloud is a hybrid cloud. And I think that's actually a valid way of using the term. But the intent with the NIST model was specifically to say hybrid cloud versus private cloud versus public cloud is just a mix of these different levels of deployment mapped together. Basically, how do I get access to it? Maybe the hybrid cloud has, well, rather, the hybrid cloud was a single interface into potentially multiple deployment models. So I might have access to some public cloud resources and some private cloud resources, but the way that I access either of those resource sets is through a separate interface that provides that hybrid interaction. Often people were talking about hybrid cloud, at least at the time that this model initially came out, which was almost 5 years ago now, if not 5 years ago now, was really looking at it from the perspective uh, of having a single portal and possibly the concept of an exchange or some other resource management entity behind that portal to determine where the most cost effective or the most effective overall solution for deploying that service was, right? Do I actually want this to be private because maybe it's going to be long running, it would cost a lot if I deployed it in a public cloud and just left it there for year after year after year? Or do I want to deploy it into a public cloud because I need additional resource beyond what I have locally, but I'm only going to use it for a short period of time? So it's a very good use of that quick turn that a private cloud can make for us. Right. So these are the kinds of questions that were being asked when we talked about defining cloud, defining the service of a cloud. And again, to me, this is really what I wanted to talk to you guys about today, and hopefully give you that sort of first model for what it means to talk about cloud. In future sessions, we're going to talk a little bit more about how people are using cloud. We'll talk about some of the services that people are using and why they're using them. But I wanted to get to at least this point today. And since I had said initially that this presentation was going to be about a half hour and then we'd have some time for Q&A, I'd like to actually open it up to Q&A at this point. If people have specific questions about this model or about cloud in general, I have plenty of more slide material that we can talk about and go into a little bit more detail on some of these things. But again, this was the basis for what I wanted to discuss. So if you have a question, you'd have to unmute yourself, but you're welcome to do so. I think you can do this yourself, so I hope you can. Yeah, guys, sorry, when I was presenting, I had a full screen presentation and I thought I was presenting that, so I apologize for not having seen the fact that you weren't seeing my slides. I am actually looking at the chat now, so if maybe that's an easier way to communicate. Are there questions at this point, or should I continue talking about some of the other slide material that I have? And more importantly, is this useful? I mean, is this good information for you guys? Is this the kind of thing that you'd like to see and see more of? Yeah, James, sorry about that, and Mike, I'm glad that that I haven't left any lingering questions. So thanks. Can't unmute. Let me see if I can figure out why that would be. Yeah, actually, I can't unmute anybody. It doesn't look like. Well, guys, thanks at least for sticking through the initial technical hurdles that we've had. I will actually re-record this session, I think, just so that you have audio with a slide to look at, rather than just my audio in the background. Although, hey, maybe audio is enough for some folks. Um, what I think I'll do, if there are no questions, since we have an hour, and if people are interested in sticking through another, sort of 20 plus minutes, I'll talk a little bit more about. Yeah, so I think we'll just sort of talk about some more of the concepts. I wanted to talk a little bit about sort of how we got here, because um, to me, clouds and the applications behind clouds are really the reason that we're talking about this. Um, I find it interesting. I've been in this industry for 20 plus years and have both managed systems and thought just about, my space is the only space that the world exists around. Having been a sysadmin for many years and then a data center admin for a number of years as well, running field teams, selling products, doing all the sorts of things that I've done over the last 20 years. One of the things that has always struck me is that it's so easy to fall into the cycle of thinking that one technology answers all ills or resolves all the problems that we might see. But if we think about how applications have shifted, and specifically how the development of applications have shifted, I think it drives one of the reasons why cloud has become such a compelling and important component in our industry. Um, and if we look at sort of the initial sorts of applications that people built, well, these were software applications, or the very early days, pluggable applications that defined how services were supposed to be deployed, and they were tied specifically to the computer that they were built for. Often, and even in the case of something like an analog computer, the computer and the application were one. Basically, the controls built the computer. If we looked at things like ENIAC and some of the early compute systems of that nature, there were software programs. People did actually program the system, but it was often in a very laborious sense. So a very slow process of programming it, but you did actually have a flexible computer. It could do multiple things. That was one of its real benefits. But one of the interesting things about the monolithic stage was that effectively the developer and the software manager and the operations manager was the same person. Somebody would write the program, and often they would then actually implement the program themselves and operate the system, because there was no operating system. It was you working directly with the computer. It was a very, very tight coupling. Um, when we moved to distributed environments, we saw a real shift. Whereas it used to be one tightly knit team that developed the application, developed the computer, programmed the computer, did everything as a team. There was effectively one system. There was no separate systems administrator or storage administrator or network administrator. Everybody sort of worked together to make something happen. As we got to many smaller computers, sort of the distributed computing world, we suddenly saw this massive shift in that there were folks that only wrote applications. There were folks that only managed the system itself. There were folks that then managed the different components of the system as the system became more and more distributed. People that only managed network, only managed storage components, for example. So we saw all those sort of components come together. And lastly, we saw this disaggregation of that one solid team. Yes, there was still sort of an IT group that managed maybe a bunch of these things together, but within that there were very siloed complexes. What we're seeing today, though, especially with web scale application development and the ability of automating your infrastructure and automating your services through this cloud model, is that suddenly the developers have come back into that one team that manages everything. A development team would actually manage the infrastructure that they're consuming by automating that infrastructure deployment, by using this on-demand self-service capability for getting their infrastructure deployed, managing the long-running state of that service, and also writing the software and managing and manipulating the software itself. So really, suddenly, the developer became that end-to-end resource for managing the application. And that's the shift that we're seeing. And I would say, actually, even beyond this, today we're seeing another shift, which is that we're again seeing a disaggregation of these resources, and that the container model changes the application developers' approach to infrastructure, separating out the infrastructure resources from the actual application deployment resources. And that's a big shift that I think is just starting to take hold now. Not that containers are new technology by any means, but I think the way that they're being consumed in the capacity and quantity of consumption is really sort of changing how these things are being defined. But I think we can see this application history driving also how computing resources are consumed. If we think about it from that perspective, in the monolithic stage, it was all for one and one for all. You wrote your application, you owned the computer effectively when you wrote the application, and that was really all you had available to you. In the distributed sense, the resources were still very expensive, they were very large potentially, and you still had to get a share of it, so you had somebody who managed what you had access to. And that sort of is anti the cloud model that we have today, where we're trying to share an elastic set of resources, yes, against some limits, but those limits are much, much, much larger than we ever would have seen in the past. And that's, I think, the big shift that we're starting to really see that's driving this big change. So we can look at this another way. This is a diagram that I think sometimes makes it a little bit more clear. We used to look at special hardware with a specialized application, and potentially, if it even had an operating system and wasn't directly written to the machine code itself, a specialized operating system that ran on that hardware. And it was all in one and one for all. Often the software developer and operating system manager were the same person or the same set of people that managed that kind of resource. In the microprocessor and mini computer sort of days, yes, we still potentially had a specialized operating system, an operating system that worked for that particular computer, but there were many more of them, and so we ended up with a specialization just to manage that operating system, a specialization just to manage the distributed storage that might have gone through that distributed systems environment. And the application was something that was then layered on top of that environment, and potentially the systems operators also had to deal with how that application ran, making sure and maintaining that application environment. And then lastly, we see the model that looks a little bit more like it does today, where we might have entirely virtualized operating systems and applications, but because we've virtualized them and we've given the developer potentially the access to those virtual resources because they have this on-demand capability of doing so, we've seen a big shift in the number of applications and how they're being deployed, and the fact that really the developers are also the operators in many cases today. Now, I would say there's probably a fourth layer of this that can now be added to this today, which is the container model, where the application developer view of this system is really just the fact that they have a bunch of applications that get deployed, and not so much that there's an application tied to an operating system tied to a physical system. And that's a big shift that's also happening, and that ties into this same on-demand service. It's only because it's so easy to request another resource, to request another web server or another web endpoint, really, if I'm not even thinking about the physical server or the virtualized server anymore, but just my application component provides a web service endpoint, basically a web address that I can actually go query. And if I don't care about the operating system anymore, I don't have to manage the network connectivity anymore, I don't even really care about the storage, just as long as I have somewhere to store the bits that I need to store. That's a big shift that's happening, and it's being driven by the application. So really, cloud, if we want to think about it this way, is the application environment rather than the actual underlying systems environment. But in order for the cloud to work, I need elasticity, I need to be able to measure the resources, I need to be able to pool them, I need to be able to get access to them from anywhere I'm at, and most importantly, I need to be able to do that on demand through a self-service interface. So, if we look at all these pieces, again, application developers are the ones that are driving this request. They're saying, hey, I need this capability. And why do I need it? Because I can actually get my job done more rapidly. I don't have to overburden IT departments by asking for resources and having them manually potentially create these resources. Or even when they had it automated, still putting in another step in the process of trying to get a resource available for doing development. So we really do accelerate the development. And classically we talk about, I grew up in a world where the waterfall development methodology, if you guys have run into that, was basically the only way we thought about things. You had a period of time where you did development, and you had a period of time where you did quality assurance, and you had a period of time where you did further integration and quality checks, and then finally you might release the product. And a product release cycle might be on the order of months or even years for many releases. I think many of us lived through that particular era. What we're seeing today, though, is that product releases are potentially happening on an hour-by-hour, if not even minute-by-minute perspective. If I can create a feature and function and test it and validate it at some level of system scale and then roll that out into production that really changes how I build my applications. It changes the ability to be responsive to customer requirements and demands, because it's a lot easier for me to say, well, if a customer is saying that they really don't like the background color because they can't read the text on my page, and I can change that parameter almost instantly after having tested to make sure that that doesn't break something else somehow in some odd way. That's an incredibly powerful component, again, driven by the application itself. Right? We're not driving these changes by the infrastructure. The infrastructure is supporting a change that enables better application deployment and services. So really, we have a new development paradigm. Right? I can now develop much more rapidly. Now, not everybody does what somebody like, I think Airbnb was saying that they potentially release to production 300 or 400 times in a month. Very few people are at that particular rate of scale. But the fact that there are people that can actually now do this, they can use these automatic elastic resources to build their systems and release at scale multiple times in a day even, whereas in the past it would be multiple times in a year that you would release something. That's, I think, a really impressive capability that the cloud has brought to bear. So really, we're looking at how we enable this. We're looking at how these services can actually make the cloud a better space, but it is driven by the fact that the cloud enables this for all of us in a much more functional fashion. So while the cloud is this great and wonderful thing, and I think in most cases, if you can use it, it's a great thing, there is something that people talk about when they talk about cloud, which I probably ought to add a slide to this deck at some point about it, and it's this concept of pets versus cattle, or named resources versus unnamed resources. Resources that you have to care about because the resource itself is the thing that makes everything go, versus a resource that you can delete and recreate. My world at work today is effectively one where I'm constantly deleting an entire environment and rebuilding it. I mean, my test environment gets rebuilt at least 4 or 5 times in a day. Now, part of my deployment process takes hours, so it's not like I can do this on a second-by-second basis. But that's because I have a lot of systems and a lot of components that are not quite as flexible or functional as the container model might let me get to at some point in time. But the concept that an application might be more flexible is great if your application is. There are still plenty of applications that were never built with this kind of flexibility in mind and actually don't do well in infrastructure that fits into the cloud space. Now, the reason for this is that most people build cloud systems without the same level of care and performance and resiliency that they might build a classic enterprise data center environment from. Classically, because systems were expensive, because the software development cycle was so expensive, you would build a system and you would potentially provide some resiliency or redundancy for it, but you'd provide multiple network links, multiple access paths to storage so that any one path could fail and your system would continue running. In some cases, people even built hardware that was internally, x86 class hardware, for example, that was internally resilient. It could deal with an entire CPU dying and yet still keep running. And there are certain applications which need that level of resiliency even today. But the change in how applications were possible to be built, specifically I would say the Amazon Web Services change in application deployment, really made a major shift in how people thought about applications and what they could do with them. So applications started to be built to fail so that you could recover rapidly from a web interface failure. And actually, we've been sort of trained to deal with these failures very, very often. And actually, now even the web browsers have gotten smart and sort of deal with some of this for us. Much like our use of cell phones has trained us to expect a call to not always work, expect a connection to potentially die in the middle of a conversation, and we just recall that redial into that conversation. That kind of training has happened even in the web services space, where we expect that occasionally we'll get an error and the system will just automatically retry for us, or we'll click the refresh button and get right back to where we were. Our shopping cart, if we were on a website where we were trying to buy something, will still have all of our resources in it. And that's because of a number of changes in the application deployment model. But if those changes haven't been implemented, then that application may not fare well in a classically deployed, or at least what I now think of as a classically deployed cloud environment, because the infrastructure was never intended to support the level of resiliency that a non-web scale application expected? So that's actually, I think, a really important question to ask when looking at the applications in an environment, when looking at, is something really cloud enabled or cloud ready or not, right? Because not everything is, and there are still plenty of applications that are the backbones of businesses that are by no means ready to be turned into cloud scale applications and thrown onto an Amazon Web Service, for example. So very important components. And at this point, I've been talking for about 50 minutes, and often I find that's about what people can actually handle. We do have another meetup scheduled, and I think it's in 2 weeks. And we were going to talk a little bit more about how customers are, or how companies and customers are actually using these different cloud resources. Um, if you haven't registered for that meetup, and if this one was interesting to you, please go to the meetup page, look under our Cloud Basics meetup group, and register for that cloud session. I promise I will figure out the PowerPoint presentation much more efficiently next time, and we'll actually have PowerPoint throughout the entire thing rather than just on occasion. And we'll certainly be posting the link to the recording of this, which I hopefully will be able to get to re-record sometime in the next couple of days, and actually have slides throughout the entire session as well. If there are any additional questions at this point, let me know if there are additional questions. You can either leave a question within the chats or on the meetup group. And in any case, thank you so much for listening. Thanks for joining, and looking forward to the next session.